The monthly profit of a canning factory is a function depending on the capital X invested in advertising in the regional TV, measured in €1,000, and capital Y invested in advertising in national TV in €1,000 too. This function is given by the expression b of xy equals 80x divided by x plus 5 minus 2x plus 40y over y plus 10 minus 2y, measured in €1,000 as well. The total advertising investment budget is €25,000 per month. Calculate the optimal advertising investment and the optimal monthly profit. In this problem, we must look for the quantities x and y which maximize the total profit measured by the function b, subject to the condition that the total advertising investment budget is €25 per month. As x and y are measured in units of €1,000, this condition can be written as x plus y equals 25. As this is a linear restriction, we can use the substitution method. I work out in the restriction the variable y, for example, and I have y is equal to 25 minus x. Now I replace y in the objective function, and I have v depending on y is 80x over x plus 5 minus 2x plus 40 times 25 minus x over 25 minus x plus 10 minus 2 times 25 minus x. Doing the calculations, I arrive at the function b depending only on x given by this expression. Now, to calculate the critical points of function b, I must derivate it and then make it equal to 0. To derivate this function, I use the division rule, which is the derivative of the numerator times the denominator minus numerator times derivative of the denominator, which is 1 over denominator squared, plus the same rule, and I get this other expression. Doing the calculations, I get that the first derivative of v is this function. To calculate the critical points, I make this equal 0. I can simplify the number 400, and I have 1 over x plus 5 squared minus 1 over 35 minus x squared is 0, which is 35 minus x squared minus x plus 5 squared equals 0. Doing the computing, I get that the value of x, which makes the first derivative equal 0, is x equals 15. To know if this is a local maximum or minimum, we must calculate the second derivative. Here we have the first derivative, and the second one is derivative of the numerator 0 times whatever minus numerator times derivative of the denominator. Sorry, the derivative is this one, over the numerator squared minus derivative of numerator 0 minus numerator times derivative of the denominator. I must multiply now by -1, so this would be a plus sign over 35 minus x raised to the power of 4. So we get minus 800 times 1 times nothing over x plus 5 cubed minus 800 over 35 minus x cubed. Now we replace the value of the critical point and we get minus 800 over 20 squared cube, minus 800 over 20 cube, which is a value less than 0. So we can conclude that x equals 15 is a maximum of the objective function. To know the value of y, we must replace x in the restriction, and we get that y is 10. To know the value of the maximum profit, we must replace the values 15 and 10 in the profit function, and we get a value of 30 units. So the final answer would be the optimal advertising investment should be 15,000 euros in regional TV and 10,000 euros in national TV each month. With that investment, the maximum monthly profit would be 30,000 euros.